Okay, yeah. So my title there, thinking about really the last several thousands of years, and many of you have been involved with work here in the with the what we call the interstadial wood or subfossil wood, and I wanted to talk about the treating records, which I think interfaces nicely with some of the other presentations. And so I'm from the College of Worcester in Ohio, where we keep a lot of the wood on loan in our treating lab down there. So I'll start off by talking about when I first met Greg at Bering Glacier in 1993 in June, and in the shadow of Stellar Mountain, which was kind of appropriate. Just heard about Stellar sea cow and such. The great naturalist there, another great naturalist, and Greg was the first my memory was. He made our entire camp, which I think was 15 people, move because there was a plover bird nest in the middle of the area, and so that was the first experience. And then he helped me out immensely that few days, basically sampling wood out in front of Bering Glacier, which was in surge mode at the time. So it was pretty spectacular. The other thing about so there's Stellar Glacier and Greg on that side, and the naturalist Austin Post, who was also on the trip. They were best of friends, and it was quite a remarkable friendship. I recall that as well. That was Greg was an amazing friend to Austin at the time. And furthermore, I was a graduate student coming from New York State, and the glaciologists and the naturalists really helped me out in terms of setting up a floating Zodiac with a generator, 3 chainsaws, and we were cutting up the subfossil wood there at Stellar Glacier and Bering Glacier. And so it's kind of similar to what Dan just showed, that these glaciers, as you know, running over a big forest, and we're archiving that wood from all over the Gulf of Alaska. But really the Rosetta Stone here is in Glacier Bay. And it took us a while to get here. And Lewis said we've been here 15 years working on it. But that's what this is showing here. These trees were run over during the Little Ice Age, 1200 CE or AD. And this is some of the wood sampled just a few years ago in McBride Inlet to the right, looks reminiscent of a totem sticking up there now as we speak up in McBride Bay. That's 8,000 years old, so we have wood that goes back quite some time. Nick Wiesenberg, who's watching the students over at the UAS campus now. We're working with students who we just got back from Mangoon, and Nick is our technician who has been working on these projects for quite some time, along with Ben Gagliotti and Dan Mann and many other people in this room. And that's wood along the sampled 4,000-year-old wood, so radiocarbon dated 4,000, along the East Arm shore, and has several hundred rings in it. So that's kind of our raw material. And like I said, you can see over here, a little fuzzy, but all those individual dots are where the wood comes from. And there's multiple generations of wood going back to 8,000 years up and down the fjord. And I'm sure many of you have been involved in the sampling of this with Dan Lawson and others. So Dan wasn't able to be here today, but from Crowell, retired. Now lives in Vermont, and down below there is Nick in our lab with 600 cross sections from Glacier Bay, along with thousands of cores from the high mountain regions all around Excursion Ridge back up into the bay. So all that information is kind of an archive of history, and we call it subfossil wood. Some call it the interstadial, and we have several students and collaborators all over the world, which we'll talk about, where the wood is being analyzed. So this is kind of a summary diagram. Whoops, got both. Yeah, so the wood goes back down below here, about that's 10,000 years, about 8,000 years, and we can see that the green here is what we have calendar dated, so we're able to match the ring patterns going back in time, about 4,000 years now, which is one of the longest continuous triggering chronologies annually dated in the world, top 7 or so. and hopefully we go back further with more work over time. So what good is that wood? This is the work about 3,870 years. And just to point out some things, luckily Dan showed some good graphs, and I'll try not to show too many, but the ups and downs in this, it can really be thought of as temperature and a really long season temperature, like in January through September. So this is ring widths, so the growth of the trees. High growth during the warm times, low growth during the cold times. And Dan pointed out some different time periods like 1697, 1699, perhaps a continuous winter for a few years, and that's dated, and Dan mentioned, perhaps with volcanic events that occurred in the northern hemisphere and decreased the ring growth. So those kinds of events in there. The other thing that pointing out here is a group at the University of Arizona that's taken this wood. So we send the wood off to various labs, and they analyze it. And this is showing 993 CE, 774, and 664 BCE. These are some kind of catastrophic atmospheric events, perhaps a comet. The atmosphere is perturbed, and there's a high amount of carbon-14 that's produced in the atmosphere, and the trees take it in. So every tree ring chronology around the world has those particular years that can be analyzed by your geochemist, and you see a big spike in carbon-14. So that's kind of valuable. It tells us we're on the right track, the timing is right, because that is a calendar date all around the world, which is pretty interesting, and they're all here right in Glacier Bay. The other things, we really haven't published this yet, so we're just kind of revealing it here today. But we can see the warming Dan talked about, the contemporary warming, and put it into a longer term context in that sense. Other work, Ben Gagliotti at UAF. So once this wood is dated, calendar dated, then we can send it out to researchers who are innovating all the time in terms of wood anatomy, and this is Ben's work. And Dan working at looking at the rings that are basically recording trauma. So you can see the stand of trees up there that look like they've been through a lot. And so these are mountain hemlock trees that are broken tops, profound disturbance, especially in the winter. And when you think about the ups and downs of the trees, it's mostly they grow in the summer, you think. But they do record other things that happen during the winter time. So this is what are called TRDs, or traumatic resin ducts, and then we can get an idea of what the winters were like going back thousands of years in that case. Another innovation that's a blue revolution, sometimes called, Swiss, mostly done in Northern Europe and Switzerland, and various software that's been developed. And here's some Glacier Bay tree rings that's looking at the late wood of each ring. So you got the early wood, which is a light colored ring and part of the ring, and then the late wood, which is a dark color. And you look at the density of that dark colored ring. In this case, it's a proxy for density, which is blue light reflectance from the ring, which is pretty clever as a way of looking at the density. And so the things like volcanic events might be very light years in terms of color and in density, because the tree shuts down once a volcano cools the world down, the tree stops growing, which is pretty interesting. And this is actually tied into, kind of tuned into June, July, August temperatures, so it gives us a more pure summer temperature. A wiggly diagram, but going back to 600 CE there, we see the red line, which is the ring width, showing us about warming temperatures. Back here about 1,000 years ago, we call it the medieval warm period. A warm time, especially in the winters. And then the blue line, which is shown, is this blue intensity, which is showing the summer temperature. So we get a summer signal and a winter signal. And glaciologists will tell you that's mass balance, that you can look at when the glacier is melting in the summertime and when it might be accumulating snow in the wintertime. So there's a lot of different promise in looking at these kinds of lines here. One more study looking at wood anatomy. As it turns out, there's a lot of people who like to look at wood anatomy for a whole variety of reasons. And this circle in the middle, this is work done in Cambridge in the UK, University of Cambridge. And a frost ring, so this is 535 CE, which was a big volcanic eruption somewhere in the world. And the ring basically is kind of blown apart. And so if you're careful and preparing these, you can see that that ring is broke, the cells are kind of broken open during that time. Another thing that's seen in Glacier Bay wood, so this was sent out to them, there we are up there, and all over the world, is the blue rings. So if you're clever with chemistry and staining these rings, you can see that certain types of lignins are not produced 1 year when there's a big volcanic event. So the tree doesn't changes its physiology from year to year, and if you can detect that and you're clever enough to interpret it, that again showing us something happened at 535, a little different somewhere else in the world. Thank you.